Now, when evaluating then the mathematics of price elasticity of demand, one of the things, specifically using the general form, percentage change in QX divided by percentage change in PX, the absolute value of that. When analyzing this calculation, we run into an issue with regard to the direction of change. What I mean by this is think about, assume the price is initially $10, okay, and we increase the price to $20. Well, that change right there is 100%. Okay, but if the price was $20 and we reduce it to $10, well, that change is equal to a negative 50%. And even if we take the absolute value of that, you can see the difference. So the first change was a 100% increase, but the second change was a 50% decrease. And that confuses things. That doesn't give us consistency in our outcomes, and so we want to some extent standardize our methodology to rid ourselves of that directional calculation issue. And the way we do that is by using something called the midpoint formula. And the midpoint formula goes something like this. Percentage change in quantity demanded of QX can be represented as some change from Q1, some change in starting at a position of quantity demanded of Q1. Subtract from that your second position, quantity demanded of Q2, and then divide that by Q1 plus Q2 and divide that by 2. Now this concept gets its name midpoint formula because, as you can see, this percentage change in QX calculation, the denominator is at the midpoint, or the average between Q1 and Q2. Okay, that's where it gets its name midpoint formula. Now this is of course different from a standard percentage change calculation, because a standard percentage change calculation would look like this, right? But again, and you can work this out for yourself. Just plug numbers into here, changing from one position to the next, and make this calculation, and then reverse that change. Okay, so make Q1 what Q2 was, and vice versa, and do the same thing. You'll see you come out with two different numbers. Using the midpoint formula eliminates this direction issue. And continuing on, the percentage change in PX can be defined as P1 minus P2 divided by P1 plus P2 divided by 2. Okay, and then of course we would divide those and take the absolute value of them to get E sub x, and that is the midpoint formula. Now, one thing you're going to find here is the simple fact that it doesn't matter what P1 and P2 are, as long as they're consistently 1 point on the curve. in other words, it doesn't matter if I put the starting position first or the starting position second. It doesn't matter what price change I count as P1 and what price I count as P2. Why? Because again, I'm taking the absolute value of it all. So remember that, unlike a standard percentage change calculation where you would normally say take P old, you would take P new minus P old divided by P old. In this case, because we take the absolute value, we just don't care what new and old is. Okay, so keep that in mind as we move forward.